Hello students, I am Suman. Today we will discuss physics class 9 relation gravitation, and there are three topics: equation of motion, variation of acceleration due to gravity, and mass and weight. These three topics. So first we will go through first topic, equation of motion. Equation of motion for freely falling bodies. When an object fall towards the ground and when we throw the object from the ground. So when the object fall towards the ground, the equation is V equal to U plus GT. First equation. Second, H equal to UT plus half GT square. And the third equation, V square equal to U plus 2GH. Where G means acceleration due to gravity, H means height, because the object is falling from a height towards the earth. That's why in place of S we will write H, and G behaves like acceleration. In place of A we will write G. So this equation, when the object falls towards the ground, and it is opposite when the object throw from the participant's upward direction. This is equation for downward direction, and this equation for upward direction. So in upward direction, the value of G is negative, because the object is pulled by the earth and their velocity gradually decreases. That's why the value of G is negative. So first is V equal to U minus GT, H equal to UT minus half GT square, and V square equal to U square minus 2GH. So this is the equation of motion for freely falling bodies which fall from the ground means downward direction, and when the object goes in upward direction. Second topic, variation of acceleration due to gravity. Acceleration due to gravity is not uniform all of the earth. It is different for the different places, and this variation of acceleration depend on the different factors, which is first one is effect of shape of the earth. As we know that the shape of the earth is not uniform. It is flattened from the top and the bottom, means at the pole, and it is exposed on the in place of equator. So the radius of the earth is minimum at pole and the maximum at equator. So we know that G equal to Gm upon R square. We have discussed the relation between small g and capital G, where G is small g is acceleration due to gravity, capital G is universal gravitational constant, and m is mass of the earth, and r is the radius of the earth. So the radius of the earth is minimum at pole and maximum at equator. So the value of G is maximum on pole and minimum on equator, because if this value will decrease, the whole value will increase, and if this value will increase, the whole value will decrease. It means if R will increase, the value of G will decrease, and if R is decreased, the value of small g, means acceleration due to gravity, will increase. So first is effect of the shape. Second is effect of the altitude. Effect of the altitude means as we go above from the earth, so the value of G will decrease, because as we go above from the earth, this value will increase. That's why the value of G will decrease. And as we go, third is effect of depth. As we go inside the earth, in mining, the value of G will also decrease. The value of G will decrease as we go above from the ground and as we go deep inside the ground. So the value of G will decrease in both the conditions. And at the center, the value of G is g is 0. So these are the three factors on which the acceleration due to gravity is dependent. Now the next topic is mass and weight. Mass and weight both are not equal, it is different. Mass means total matter contained in an object, or weight is the mass pulled by the gravity at which rate, that is weight. Mass is a constant quantity where weight is variable quantity, because weight is depend, weight equal to mg, means m is mass and g means acceleration due to gravity. So the acceleration due to gravity is not the same, not equal for all over the universe. It is different for the different places. That's why weight is different. But mass is a constant. Mass is constant. Weight is variable. Also, mass is a scalar quantity. Why? Weight is vector quantity, because weight has direction, which direction is pulled towards the ground. So the mass is scalar quantity and weight is vector quantity. And other things, the SI unit of mass is kg and SI unit of weight is Newton, because weight is a kind of force. Force equal to F equal to ma. You know that force equal to mass into acceleration. So here in place of acceleration we will write g. So weight is a kind of force, and that's why weight, the SI unit of weight is Newton. So these are the some differences of weight and mass. And when we compare the weight of moon and on the earth, it is 1/6 of the moon. Suppose that the weight of an object on the earth is 60 Newton. So the weight on the moon of the same object is 10 Newton, because the gravitational force, acceleration due to gravity of the moon is 1/6 of the earth in comparison to the earth. That's why the weight of the object on the moon is 1/6. So, and mass is remain constant. Mass is 60 kg. It will remain constant because it is not depend on the gravitational acceleration due to gravity. So this topic has been completed. Next topic we will see next video. Thank you.